Hello everyone and welcome to another episode of AI learning web series of IntellicoTalks powered by IntellicoWorks. IntellicoWorks is a AI consulting and DevOps consulting company that provides its services around the globe. We are also the partner consultants for AWS, Azure, and Google Cloud Platform services. We will talk about one of the major phases of software development lifecycle today, which is software maintenance. When we get done with all the development part, there comes the step which is software maintenance, and today we are going to discuss that how AI can help us in that specific phase. So let's start the episode with Shahzad. Shahzad, we discuss about the software development and how we can leverage AI in the software development processes in the different phases of software development. But today, we can say it is one of the last parts in the software development lifecycle, which is the software maintenance. And tell us that how we can integrate AI in this phase, the software maintenance part, and how it can help us in the predictive analysis of the software maintenance, how we can predict potential issues and get the resolution out of it. Tell us about that.
Okay, so let's go back into the history that how actually software being managed. So software being managed in a way that there's a complete software development life cycle. Everyone is happy. Software is being deployed. It's being working. Users are actually coming in. Users are actually buying the products over there. It's working absolutely fine. Now comes the phase of the maintenance. It's been around 1 week, 1 month, 2 months, 3 months, 4 months. Software is up and running, working exactly like that. This is a normal statement. But in actual scenario, it's not. So in maintenance, it's always keep on evolving on different things. Your competitor will come to you. Your competitor will keep on scraping the data. You will have lots of data actually in the production database. You will have lots of people actually coming in, lots of audit trail, lots of things actually there which are not in production, which were not there in the beginning. So when the things are not there in the beginning, what you have to do is you have to take care of all of them. So you have to take care that how it will actually behave and interact in the maintenance part. So now lots of users, lots of products, lots of data, lots of analytics, lots of competition, lots of scraping of information, lots of other things are there. So how you can actually manage all of them? You need a complete maintenance team to actually handle all of them. Is my hardware good enough to actually handle the entire load? Is my database good enough to handle the load? Is my all the things actually good enough to handle the entire load? Yes, these are the questions that you need to ask, and you need to keep on monitoring all of them. So either you have to maintain the software, you have to improve or improvise or right size the infrastructure, or you have to fix the bugs that are happening in production due to large data, due to different data, due to different segmentation, due to different input fields. You actually test an alphanumeric on some field, and people actually go to the symbols actually in that field. They actually added symbols in there. So what your reaction would be? The performance of the website actually goes slow down because of the large number of data. So how you will react to that? So all these questions are there for the maintenance team. Maintenance team is actually more than 80% part of a specific product life cycle. You develop a product, it's running, it's actually in the production, it's there. It's exactly like the car, right? So you actually bought a car, you actually create a concept. The concept is already there. But when actually 100,000 people actually using your car and they actually hit an issue, so what you will have to do is you have to fix that issue.
Absolutely.
Regardless of the fact that you have a very, very defined and smooth process actually over there to build the car. In new model, it's absolutely working fabulous. But when it actually hit the road for 10,000 kilometer, 20,000 kilometer, 100,000 kilometer, then you have to check the maintenance capability.
I mean, that's a very interesting real world example that people think about buying a car, but it's exactly the thing is about the maintenance part, which comes later, right? So when if we go back into the time, so things about in the software development life cycle is about the development part. People develop the things, deploy the things, but there was a certain time when the issue arises, then they look into it and get it fixed, right? But today we have some certain tools like the AI tools that can predict things for us, right? So the first part in it is about the predictive maintenance. So can you tell us that how AI can leverage the historical data and performance metrics in analyzing the potential issue detections in the software maintenance?
So there was a very big player in the market in terms of automotive vehicles. I would not name that one.
Yeah.
So what they have learned from the past is that they actually believe lot of belief in the failures. Actually, they believe in failures. They believe in their data analytics. They believe in their resource allocation. They believe in all of that. Now they are the top brand. They're actually selling their cars in 100 millions. Right? Not many cars are there in the market, but they're actually selling their cars in 100 million. So the strength is they actually work on the data analytics part. They actually work on how the user drives their car. So in software, it's exactly the same. How the users are actually using the software. What are the main links? What are the hot links? Where the things are? How the things need to improve? If some pages are actually being used a lot, you can cache that page. You can cache that page to actually get things more. Some people are actually getting failure on few things. Is that failure really frequent? Is that user-generated failure or the other one? How we can use that? Some people are using actually a specific resource, specific page, specific functionality. Can you actually work on that one? Yes. It's exactly the same that people are actually so much about. In some part of the world, they are actually care about kilometer per liter.
Yeah.
Right? But in some part of the world, they actually say that how much top speed it can actually gain.
Yeah.
So leave the fuel part. Let's see how much top speed is can gain. Like
the preferences are different.
300 mile, 400 mile, 380 mile, 400 mile, 420 miles. So so they are actually going for that. So it's all about preference. So data analytics, failure pattern, and the entire resource allocation part is actually telling you about the maintenance capability. If you go to another region where the speed is actually there, they're not really care about if this is something else. So in software part, this is exactly the same. If you are in a retail business, your priorities, data analytics will be different. If you are in a commercial or communication business, your priorities will be different.
Yeah.
If you are in an apparel business, it will be mostly based on the performance.
So it actually depends on the niche of the business.
It actually depends on the niche of the customer or of the business and the customers and the mentality of the customers.
Yeah.
Like people actually started buying things regardless of the fact it is actually coming into their range, but the product is not so up to the mark. But if you actually go to another region where people are saying that, okay, we're not going to buy the things which are not up to the mark, we will buy only those things that are up to the mark. It's totally up to them. So data analytics is the most important one. And the failure is the second most important one.
Okay.
And based on these things, we actually create a list of the prioritized maintenance item, which will actually go into the bug fixing.
Yeah.
You actually create a model of a car that is so much badly hit on the road, and it is actually not giving you good enough
the right feedback from the customer. Yeah.
Return on investment, right feedback. There's a complete list of angry customers is there.
Yeah.
The model won't survive like a year or two.
Yeah.
So there is a new model actually there. Exactly same happened with the software as well.
Yeah.
So if I go back into the history, there's Asla Vista, there's other Netscape engine. But when actually there is a search engine comes into the market, that's Google, it actually rules the world for 2 decades. And still it's ruling the world.
Yeah. No doubt.
So if you keep on improvising based on your failure prediction and your data analytics, you actually go a lot extra mile.
So I would say that, in this part, he is really helping us, in the predictive analysis part, the predictive maintenance part, and it actually helps you with respect to the niche of your business or the customers, right?
Precisely. Previously, what the people actually do is they actually a big team, huge team actually of data analysts are there who actually create different segments on that one.
Yeah.
And they actually give feedback back to the product owners or the maintenance or the program manager that these are the areas that we need to focus. But with the help of AI, the computation is so fast that you can actually get a real-time analysis of the entire stuff, that which direction the data needs to be, which direction the software needs to be, and you can actually keep on going with that.
Perfect. So the next part is about the proactive issue resolution. So tell us that, can AI help us in the automated bug fixation in the software maintenance part?
The generative progressive model is all about context analysis. It has understanding of many high-level programming languages. It has understanding of, if I give them a software model and understanding, it can predict you that this software might have been built in these high-level languages.
Okay.
So if I say that I'm getting a problem in this one, If I'm getting a bug in this one, can you help me fix that one? Using the code, using the text, or give me a workaround to that one. AI can actually help you with that. It can actually give you fix for that too. If you are actually using this, you can actually use that.
Yeah.
If you're doing this, you can do that. If you're doing this, you can do that. So there is always an alternative method available for that. But if you have an actual code available, you can actually type and paste the code and actually give you that one.
So, I was, about to ask you this question that, if you present the right use case to the AI tool, so it can help you in.
It will definitely help you. It always helps you out with the right set of codes, right set of tools. Even if I can tell you that you can just copy paste the code to the GPT APIs and share that, optimize this code to like 4 lines even. It can actually help you with the 4 lines if this is possible. If this is not possible, it will say that no, we cannot actually minimize this code to this point.
Perfect.
And the most important one in the code refactoring and the bug fixing is that if you have a security element or security issue inside your code, which you actually pasted to that one, it will actually point out as a comment as well that this piece of code or these lines of code actually need to be revised so that no other security hazard can happen. SQL injection could be cross-site scripting, XSS, impersonation. It can be anything. So generative progressive model can actually predict on that one too.
Perfect. And the next part is about the AI-driven analytics for a better performance. So can we rely on AI in that part? I mean, can AI assist us in capacity planning in the software maintenance part? That is very important to, the first thing is about the predictive analysis, that you do. But what capacity do you need? The maintenance capacity. Can AI help us in that regard?
Of course. AI actually take care of all the resources and take a data from feeding from all the resources. That what type of load is actually on which server, what type of load is actually happening on which resource or which component of the entire software production deployment. So when we actually feed in all the data, it actually start predicting that this particular size of the infrastructure can handle up to this time or this much load. So 2-dimensional. So this time and this load. So if there is a nearest match to that one, the graph actually goes start going too higher on that part. It will actually start predicting, start creating alerts that okay, we need to increase the infrastructure or we need to decrease infrastructure.
Okay.
If that is totally underutilized, you can decrease that one. If that is totally overutilized, you can actually increase that one. And this happened for the on-premises one most of the time. But if you're going for a cloud one, or if you're going for anywhere, you can actually auto-scale on different things. These AI-oriented models actually help you auto-scale or right-size at any point in time.
Perfect. You talked about quite comprehensively about the maintenance part and usage of AI. But, I always ask this question in almost every episode that, can we rely on AI totally in the software maintenance part for all these steps?
Yes, we can actually rely on that for all these steps because AI can actually keep on monitoring on information, keep on getting the information, keep on getting the information if there is a predictive security hazard as well.
Yeah.
If there is a performance going down, if there's resource going down, if there is any problem that is going to happen, it keep on monitoring on that one.
Yeah.
You can set up predictive alerts as well. You can set up proactive monitoring alerts that can tell you that. And based on them, you can actually define your actions. So you're getting alert that 80% utilization of hardware is there.
Yeah.
There is a script that will actually automatically provision a new server, add it to the cluster, and the 80% actually goes down to 40%.
Yeah.
So automatically, it's this thing's already happening automatically. So larger products where the like 100, 200, 300, 1,000, 2,000 servers are actually there, how they're actually managing that? They cannot manage it manually.
Yeah.
They have to manage that using an automation tool. But
Absolutely.
if the automation tool is actually not able to handle like 2,000, 3,000 resources, AI is there.
And that helps you in in having that proactive approach.
Yes.
In the maintenance part.
Yes.
Perfect.
Yes,
so again, concluding this whole conversation that AI is quite effective in the software maintenance part. And
it helps you a lot with the reduced downtime.
Yeah.
It helps you a lot with the lower maintenance cost. It helps you a lot with the proactive alerts. It helps you a lot with reducing the total cost of ownership. Like you have the total cost of ownership, TCO, and you wanted to actually get things in better hands. So it actually helps you with that. So
Perfect.
rather than actually having a big or large team actually managing the boring stuff, so AI is actually doing that. So if the boring stuff is actually taken care from humans, then humans can actually do a lot more creative ones.
Perfect. So I think that was a quite comprehensive conversation about the software maintenance part, and how we can leverage. So we can reduce downtime. We can actually predict how many assets and resources we required for a certain level in the maintenance part, right?
Yes.
So I think that was very interesting to know about this phase of the software development lifecycle. And thank you so much, Shahzad, for being with us in this episode. And that was it from this episode of AI Learning web series of IntellicoTalks. And we will come up next week with a new episode with a new topic, that how we can leverage AI for that specific thing. So stay tuned for the next week. And thank you so much for staying with us.